So, hello everyone, let's solve physics max exam, the physics 1 2009 undergraduate question 2. Okay, so what the question tells you is that you will have a proton, so a positive charge, okay, that is going to go from here with a velocity v, and its charge is k and has q and its mass is m. Okay, so this, one second, this proton will go in here. Now here we don't have anything, okay, and then here, why does it, and then he will go this way over here where there is an electric field and there is a magnetic field. Okay, so we know the direction of the electric field. How do we know it? There is a positive charge over here and a negative over here. So where is the direction of the electric field? It goes from the positive to the negative, right? So it is like this, the direction of the field. Now notice, what is the thing that's passing? It's a proton, right? So it's positive. So where is the force that's applied on it? It's there, right? So the electric field and the force of the electric field is applied there. Now you need to remember that it's not always the case. What do I mean by this? It's a positive charge, so it wants to go to the negative charge. This is why the electric force is over here. Okay, but if it was a negative charge, you will have the electric field there but the force over here. Okay, because if it was negative charge, it would want to go to the positive charge. So just remember this, the force now in this case it is equal. Okay, so now, so what would happen? We have in this part over here, we'll have an electric force like this. Okay, but can you see that how this proton is moving? It doesn't change its direction. It doesn't go there. Now why doesn't it go there? If there is a force applied in this direction, if there is a force applied here, then it should have made something like this, right? But it didn't. Why is that? Because there is another force applied over here that will cancel with this electric force. And what force is this? It's the magnetic force. Okay, so the magnetic force must be equal to the electric force. Okay, this is just information. Now he didn't give you this is like exactly in that question, but things that you could understand. Okay, so after this, the proton comes over here and then the electric field stops. There is no electric field in this area over here, and you have a second magnetic field. Now this first magnetic field stops acting, okay, until here, and now you have only a magnetic field. So you have the force applied by this field over here. So now let's go to the questions. Okay, so the first question, give it a read over there, just so that I forgot to open the paper exam, so I can take the next questions here. Here it's open. So let's go back here. Which of the following is the correct explanation for the force acting on a charged particle under a uniform magnetic field? So now it's a question like it doesn't even have to do with anything like exactly about that picture. It's just how is the force in a magnetic field? The direction of the force lies in the plane composed by the magnetic field, and the velocity and the magnitude of the force is independent of the speed. So look, for this one, what is he like? There are many questions over here, but what is he asking you? He's asking you about this rule. Remember the right hand rule. You have, if you put these fingers where the magnetic field is and the velocity over here, you will have this the force is acting outside of your screen now, okay? It's pointing to you right here. So if you had maybe something like this, like, let me try something like this, okay? So like this would be the force acting over here, and where would be this would be the velocity. This is the velocity, and here will be the magnetic field, okay? Notice, even in the formula, what is the formula for the magnetic force? Do you remember the formula for the magnetic force? The magnetic force is equal to KBV, right? But there is a sign of theta over here. Why? Because you only want the component that is perpendicular to the magnetic field. So it's in a way that you have, this is the plane, okay? So this is a plane, your screen over here. You will have V upwards, B here, and then F is perpendicular to them. So V and B are perpendicular to each other, making a plane. And then you will have the force going outside or inside, but in a way that it is perpendicular to the plane that V and B are making, okay? So it needs to be this way. So what answer does say this? D. The direction of the force is perpendicular to the plane composed by the magnetic field and the velocity. So the velocity and the magnetic field are making a plane, which is your screen, and the force is coming outside it, okay? It is perpendicular to this plane, and the magnitude of the force is proportional. So if it makes sense, if it's faster, if V is faster, then your magnetic force is higher, okay? Is proportional to the speed. So this is the right answer, okay? C, the direction of the force. So let's just use C as an example to show what's wrong with it. The direction of the force is perpendicular to the plane composed by the magnetic field and the velocity. So until here it's right, okay? It is perpendicular. This is right. And the magnitude of the force is independent of the speed. Wrong. It depends on the speed. Okay? So let's go to the second item. Let me just take it. So over here, the second question, okay? Which is the direction of the uniform magnetic field acting in the region of the parallel plate capacitor PK, where the positive ion moves straight with constant speed? So what is he asking you now? He's asking you over here. He's asking you that if it is, if your positive charge is going with constant velocity over here, what is the direction of the magnetic field B1? Where does it point to? So how can you find this? Well, what you need to use is what I told you, that the magnetic force must be equal to the electric force. So what does this mean? If there is an electric force over here, so the magnetic force must be over here. Now you need to be careful not to say that So the magnetic field must be there. This is wrong, okay? This is wrong. Because remember, it's still the rule. What is the rule? This hand over here. I took this picture from Google, okay? Just typing rule, the right hand rule. Right hand rule. Okay, I think it's this way that you write. Okay, so look, where do you want F to point now? Now look, in this image over here, it's pointing to us, but we want it to point over here, where B will, so it will be something like this. So where we want F to point? We want it to point to the side, so that it cancels the electric force that's going there. Now where B will be, this is going to be the B field, okay? And where is the velocity? It will be over here, but it's not. So let's see where the velocity is. The velocity is going downwards. Okay, so if the velocity is downwards, so B is not there. The velocity is where? Over here. So B must be where? Right here. Okay, this is V and this is B. Try putting this finger over here, V pointing down, and then these fingers over here pointing to you. Okay, this pointing down and this pointing to you. You will see that your hand points over there. Okay, so this is the rule. This is how we find it. So where is B? B is pointing outside of the paper. Now B, the magnetic field, is pointing to you. Why? Because if B is pointing to you, V is pointing down, V and B over here, so F will point over here. Okay, just make the sign with your hand. Okay, so B is perpendicular going out of the plane. Let's see what answer is this. In the same direction of the electric field? No, it's not. The electric field is there. Okay, this is the electric field. So in the opposite direction of the electric field? No, the magnetic force is there, but not the magnetic field, so no. Perpendicular to and into the plane of the paper, so it's telling you that it's into the plane, so it's going in your screen, so that's wrong. If it was going in your screen, where would the velocity be? So these 3D graphs that I'm doing are really bad, but I think they, even though they're bad, they help. If it was going into the screen, okay, if this was B, okay, if this was B, now we know that for a fact we need the force to be over here. Okay, so where would our velocity be? Our velocity would be going upwards, okay, because it's a proton. So if you put your thumb over here, this is your thumb, and here your fingers, okay, here will be velocity, here will be V, and there will be the force. Okay, but for our case the velocity is going down. Okay, so this is why it's not into the plane, it's going outside the plane, so wrong. Perpendicular to and out of the plane of the paper, this is the right answer. From up to down in the plane of the paper, now no. From down to up, no. He's telling me that it's like this B, so yeah, this can't be. So let's go to question 3. So now we start having a bit of math and some equations over here. So which of the following is the correct relationship among the speed v of the positive ion passing through the slit S3, the magnetic of the electric field E, and the magnetic of the field B1? So what's he telling you? He's asking you about this one over here. So he's asking you I even forgot because of the kitten. What is he asking us? He's asking us the velocity. Okay, so the velocity that is going out. Now how can we find this? Well, again by this relationship over here. How is that? What is the electric force? Fe is equal to what? It is the charge multiplied by the electric field, right? What is the magnetic force? It is what? The charge multiplied by the magnetic field multiplied by the velocity. No need for sine theta since it is perpendicular already, okay? So what are we going to have? We are going to have that Ke is equal to Kb V. So the charge will cancel and we are going to have that. And this is B1, okay? Not B2. B1. So V is equal to E divided by B. Now let me see if he gave us this expression. He gave us over here E divided by B1. Okay, no need for the mass right now, for now at least. So let's take the next question, which will be 4. So what is the radius of the circular motion of the positive ion after passing through the slit S3? So what is he asking you now? Now you will go over here with what velocity? V, okay? And then what forces are acting on you? Now the only force acting on you is the magnetic force caused by the magnetic field B2, okay? So what's happening? Why are you making a circle? Why are we making this circular motion over here? Because of that rule, of the right hand rule. So when you enter, you will have a magnetic field acting, a magnetic force acting like this, right? Did he tell you where B2 acts on? We can know where B2 acts. Where is the direction of the field of B2, the second magnetic field? Where is its direction? Notice, just do the right hand rule. The velocity is over here, okay? So and the force is over here. Now the magnetic field must be going outward in your direction, okay? Look, these fingers over here are pointing outside of the screen, okay? This finger over here is for the velocity is pointing downwards, and these are pointing outside, okay? Outside, and the force will be over there, okay? So now the thing that we need to remember is that what is the force for something to make a circular motion? It is the centripetal force, which is equal to m multiplied by centripetal acceleration, right? What is this acceleration? V squared divided by the radius. What is causing this force, the centripetal force? It is the magnetic force that causes this. Kb2 multiplied by the velocity, okay? This velocity doesn't change, okay? So Why doesn't change? Because the magnetic force just changed its direction. Okay, so we'll have that R is equal to mv squared, not v squared because this v will cancel with this squared, divided by key b2. Okay, so this is the radius. Now if you need to, you can use this expression for the velocity and substitute it over here. Okay, if let's see the alternative, if there is some, let me just see, mv kb2 mv, there is this alternative over here, mv kb2. Okay, so now let's go to the last question, which is number 5. So for question number 5, consider the case where a proton and an alpha particle are emitted from the ion source. What multiple of the radius of the circular motion of the proton is that of the alpha particle? So now the thing that you need to know over here, that the question is not given you, but you need to know. So let's call, if the proton have a charge of 1 and a mass of 1, okay, and the alpha particle have mass of 4 and charge of 2. Okay, how do you know this? You need to know it. This is the alpha particle. It's like you know the proton, you know that it's 1, it has mass 1 and charge 1, right? This is the alpha particle. Okay, now there are other questions from the Mext, I think 2008, that uses the alpha particle. So you need to remember it has mass 4 and charge 2. Okay, so why are we telling you this? Because notice over here, the radius of the proton is going to be the mass of the proton multiplied by the velocity divided by key b2. Okay, this is the charge of the proton, mass of the proton. Okay, so the moment we make an alpha particle goes through here with a velocity v, what's going to happen? It's going to get over here, and the things that are going to act on it are going to be the radius of the alpha particle is equal to the mass of the alpha particle multiplied by v divided by the charge of the alpha particle b2, which is equal to, now the mass of the alpha particle is 4 times this, the mass of a normal proton. Okay, and the charge is 2 times. Okay, so vb2. Now notice what we are going to have is that the radius of an alpha particle is equal to 2 mv divided by kb2. This part over here is the radius of the proton over here. Okay, so the radius of an alpha particle is equal to 2 times the radius of the proton. Now let's see what is he want. What does he want? Stay calm, don't put this yet. Consider the case where the proton and an alpha particle emitted from the ion source. What multiple of the radius of the circular motion of the proton is that of the alpha particle? So it is 2. He's asking you what multiple of the radius of the circular motion of the proton is that of the alpha particle. Okay, this one over here is 2. Okay, so what is the concept that we did is that you would have done the same thing. Okay, for the alpha particle you would have over here, like, what's acting on it, the mass of the alpha particle multiplied by v squared divided by the radius of the alpha particle must be the charge of the alpha particle multiplied by the field multiplied by the velocity, cuts, and here we will have that the radius of the alpha particle is m alpha v divided by k alpha b2. Okay, so the same concept. What you needed to know, the information that the question didn't give you, and you need to know it. It has came other times. Is the mass of this alpha particle over here. So this is it for this question. Let me just find the other question that there was an alpha particle about it. Okay, so I think it was 2008. I saw it these days over here. So let me see over here. Yes, 2008. Now it's a different question, but over here, 2008. This is a question of from 2008, question 1 point. Let me find it. 1.5. Okay. Over here, physics. Okay. So consider the case where a proton and an alpha particle are in. No, I didn't take it. 1 second. Here. Yes. Now this is the question. Okay. So in the alpha decay of a uranium nucleus, with has a mass of 238, and this is the number of protons and this is the total mass. What is the ratio? Now first, what is an let's read the question. What is the ratio of v divided by big V of the speed? Small v is the emitted alpha particle of the speed v, and the speed big V is the daughter nucleus. So what does this mean? When this uranium nucleus gets an alpha decay, it will emit an alpha particle. Okay. Now you need to know, as we told you, that the alpha decay, the alpha particle, mass 4, and here 2. Okay. So notice it has 2 protons, okay, plus a uranium. But notice that it can't keep its mass because it lost 4 of masses, so it will need to be 234. And here it was 92, but it lost 2 charges, so it will be 19. Okay, so this was it's like you had this big body over here. Okay, and then it will explode. Okay, and you will have a small v or a big one for the alpha particle, and here big V for the Yukon, which is going out. Okay, so what you have over here is alpha decay. So you needed to know the alpha and you need to know the conservation of momentum. The mass of alpha multiplied by the velocity of alpha must be equal to the mass of the uranium multiplied by big V, the velocity of uranium. Why? Because it will conserve the momentum. In the initial there was no momentum, so its sum must be 0. Okay, so the mass of alpha multiplied by this V must be equal to the mass of the uranium multiplied by big V. So we don't even need to use these charges over here, but in our other question we need it, right? So what can we do now? Well, the mass of alpha is 4 multiplied by small v is equal to 2034 multiplied by big V. Okay, so he wants what? He wants small v divided by big V. So small v divided by big V is 234 divided by 4. This divided by 2, and we'll have divide by 2, 1, 2, 0, 1, 4, 7, 117. So 117 divided by 2. Now let's see if you needed to do this. You don't need to solve this, right? Because the moment 117, this is not a square root, okay? This is just the way I divide, okay? So how can you divide one? This is the end of the question. Like, you just solve this. 117 divided by 2. So we'll have 5, 10, 1 and 7, 8. 8 will give us 16, and then we'll have 1 left, 0 and 5. So this is the answer over here, okay? So this is it for today.